All right, we're going to cover example 1 from chapter 2 in the textbook. On this type of problem, what you're going to see is that you're going to be given one or two of the trig functions, and you're going to have to come up with the other 4 or 5. So there's 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. And you're going to have to come up with all 6 of them. So let's look at what example 1 says. Using identities to evaluate a function is the type of problem we're looking at. Use secant u equals -3/2 and tangent u is greater than or just greater than 0 to find all 6 trig functions. When this one pops up, that's not a lot of good information. It's not the best, but it does mean one thing. It just means tangent's positive, and you're going to need to know that when we get closer to the end of the problem. What I like to do at first is I write down, I make an answer sheet, and I write down sine u equals, cosine u equals, that's going to be tangent. I don't know why I wrote it like that. Tangent u equals. And then what's related to sine, if you forget sine and cosecant are related, you can always go back to your identities, and the very first one here says sine is 1 over cosecant. It basically means sine and cosecant are reciprocals. Also, cosecant is 1 over sine, so it means it's the reciprocal. So I like to write the reciprocal ones across from each other. So sine, whatever sine is, I'll put over here. CSC u equals, and then secant u equals, and then cotangent u equals. All right, so that's kind of going to be my answer sheet right there, and I'll work the problem out. First thing is I have one of these. They gave me secant u is -3/2, so I go, okay, secant u is -3/2. So when I know secant u is -3/2, I immediately know that cosine is the reciprocal of it, so this is -2/3. Notice that it's still negative, you just flipped it upside down. And I don't have sine or cosecant. I don't have tangent or cotangent. But they do tell me tangent is positive, so that's very nice of them. What I'm going to do is I've got to find sine. And the way I'm going to do it is I've got to use my identities. And the most important identity that is out there is on this sheet, and it's the Pythagorean identity, especially the very first one right here. Sine squared u plus cosine squared u equals 1. Now, those are u's on this sheet. This is the identity sheet. They could be x's. You could say sine squared x plus cosine squared x equals 1. Or sometimes you'll see thetas. It'll say sine squared theta plus cosine squared theta equals 1. As long as these letters are the same, and they should be if you're whatever problem you're working on. But they'll use u's and x's and thetas and t's and all sorts of other letters. So what we do is, in order to use this, we're going to write it down. I'm going to write the identity sine squared, and you can put x or u or whatever. I'll put sine squared u plus cosine squared u equals 1. Now I know what cosine is right here. So then I'm going to make a little bit of a change into what's happening here. And I guess I need to make a side note. If you don't know, if you haven't seen sine squared u or cosine squared u before, this is how we basically write sine squared u just means basically sine u times sine u. Or sine u squared. But the way that you're going to see it written more often than not is we're going to put the square next to the sine, so we'll say sine squared u. This is actually a little bit different. The reason we don't put the square right outside, so we don't say sine u squared, because that makes it seem like the squaring is with the u and not with the trig function. It's the trig function that's getting multiplied twice. It's not, this would be more like sine u times u, like that. That would be sine u squared. So when you see the squared, or you have sine times sine, it makes sine squared, and we put it on the, like right next to the end. All right, so here's what we're going to do. we're going to take our sine squared u plus cosine squared u equals 1. And we are going to replace, I'm going to go ahead and write sine squared u again, plus whatever cosine is squared. This says cosine is negative 2/3, like that. There, so sine squared u plus negative 2/3 squared equals 1. Where did this come from? Well, I had cosine squared u right here, and I just replaced it with negative 2/3. Now you can know how to square a fraction on your own, or you can use your calculator. I'll do both. I'm just going to grab my calculator and put in negative 2/3 squared. But the more we do this, the more you should not have to rely on your calculator. It makes, as you can see, 4/9. Where are they getting that? Well, when you square a fraction, you basically square the top and the bottom. Negative 2 squared makes 4, and then 3 squared makes 9, and it is positive. Anytime you square something, it's always positive, because 2 squared is 4, and so is negative 2 squared. So we're going to go plus 4/9 equals 1. And then what we have to do is we will minus 4/9 from each side. We want to get the sine squared u to be by itself. So we'll minus 4/9, minus 4/9. And we will have sine squared u equals whatever 1 minus 4/9 is. Again, you can use your calculator, but I'll do both. If I just did 1 minus 4/9, it's 5/9. But you should be able to do that without the calculator. If you think of 1, just think of it as 9/9. 9/9, take away 4/9 is 5/9, like that. All right, then I'm going to come over here and I'm going to write sine squared u equals 5/9 again. Now to unsquare anything, you do the opposite of squaring, which is square root. So when I say sine squared u is 5/9, I want to unsquare it. So what I'm going to do is I'm going to put a square root on both sides. Now typically the rule is when you square root, to unsquare, you put a plus or minus over here. This all just crosses out, the square and the root, and you get sine u equals positive or negative square root of 5/9. Now you might have some trouble with your calculator on this, and your calculator might just give you decimals. If you're saying, well, what is the square root of 5/9? I can throw it in this calculator, but it just says 0.745, and that's not what we're looking for. I can even hit this toggle button a few times, and it doesn't turn it into a fraction. So instead of doing that in your calculator, when you square root a fraction, just think it's the same as square rooting the top and the bottom. So this is sine u equals plus or negative. If you square root of 5, it's still square root of 5, but you can square root a 9 and you get 3. So sine u is either positive or negative square root of 5/3. I want to figure out for sure which one it is, though, so I'm going to go back to that thing that I said this is a hint. It's not the best hint, but it will help us know if sine is supposed to be positive or negative. They're telling you tangent is positive. Now, in case you didn't know, tangent is really sine over cosine. So tangent's supposed to be positive because they told us right here. Tangent's positive. And tangent is sine over cosine. Well, here's the thing is cosine's negative. So if I put sine over cosine and got tangent, sine would have to be negative because negative over negative would get you a positive. So sine is the square root of 5/3, but it's going to actually be negative square root of 5/3. I hope I didn't go too fast on that thought process. If you know tangent is positive or negative, tangent is made up of sine over cosine. So if tangent's positive, then either sine and cosine are both positive, or if tangent's positive, sine and cosine would both have to be negative. If, say, tangent was negative, then what you would want is you'd want one of these to be positive and one of them to be negative. But since it's positive, we want them to match. You basically, if tangent's positive, that piece of information means these guys should match. All right, now you have more of the chart here filled out, or more of our answer sheet. So what we do is, to get our CSC, you've got to reciprocal this, which would just be -3 over the square root of 5. But one thing I've always said is you can't have your final answers have square roots on bottom. Again, I'm going to show you how you can take care of that with the calculator, and then I'll show you that you really don't need the calculator. If I threw this in here, the calculator does a really nice job of just go ahead and fixing the square root on bottom problem for you, and it says -3 square root of 5 over 5. The trick I always say is when you have a square root on bottom, just bring it up. So bring the square root of 5 up, and I know I'm out of room here, but you'll have -3 square root of 5 over, and then you leave the number 5 below. So to take this and turn it into that, bring the square root of 5 up and leave a 5 below. So your actual answer is -3 square root of 5 over 5. Maybe I can show you on here a little better. To get from this to be fixed so it doesn't have square root on bottom, you bring the square root of 5 up and put it here next to the 3, and then just leave the number 5 below. Just like that. And when you're doing these trig problems, that's going to happen a bunch. So the more that you get used to seeing it, the quicker it goes. All right, now you got 4 things. You have sine, cosine, you have cosecant and secant. You just need to get tangent and cotangent. Going back to this, tangent's not hard to do. Tangent, and I'd use this one. You see tangent is mentioned up in this first section here of the reciprocal identities, but we want to use what's called the quotient identities. Tangent is sine over cosine. If you have both of those, tangent's pretty easy, and we have both of them. So tangent is whatever you got for sine divided by whatever you have for cosine. So it's negative square root of 5 over 3 divided by, or over, -2 over 3. One thing that's nice to know is when you're dividing two fractions, if they have the same denominator, like the fraction on top and the fraction on bottom, you really could just cross them out. And we end up with the negative square root of 5 over -2, or just positive square root of 5 over 2. Of course, if you don't remember some of that, let me show you how with the calculator here. I want to put that sine over cosine. I start by hitting my fraction button. And then sine was -5 over square root of 3. So I'm actually going to hit the fraction button. I'm going to hit this button again. That'll let me put negative square root of 5 over 3. And then come down here, and cosine was -2 over 3. So I'm going to hit this and go -2 over 3, like that. And that should tell me 5 over square root of 2. And then let's finish this problem right here. If you know tangent, you know cotangent. You just got to flip it upside down. It's going to be 2 over the square root of 5, which you know is not acceptable. So the trick, bring the square root of 5 up, leave a number 5 behind. So I'm going to bring the square root of 5 up, and then I'm going to leave the number 5 behind. And that's the 6 answers that we get: sine, cosine, tangent, and then the reciprocals: cosecant, secant, and cotangent. All right, that's example 1, and how to use your trig identities given 1 or 2 pieces of information, how you can use that to figure out all of